Alright, so this is my belated Sprint 2. We'll run the game, implemented AABBs, and the visitor pattern for collision. So we can see our spaceship. If we rotate it around, the AABB stays correct. And we can properly collide with bounding spheres. Over there, alright. And that all works great. And the way it did that. So collidables are composed of a collision volume. Collision volume is a base class for AABBs and bounding spheres. Collision volume has virtual methods for testing collision with collision volume, AABB, bounding sphere volume. That's where the visitor pattern happens. So if we take a look at an example, here's that visitor pattern. Here's that initial single dispatch, and then this call does the double dispatch. And then down here you would have all your specific interactions between bounding sphere AABB, bounding sphere. I did run into the issue of I wanted to avoid duplicate code, so I ended up doing something like this where it like just ships it over to the other one. And you mentioned it'd be better to put it in a central math class, and I'm probably going to do that next week because this is going to get finicky. And to set the collision volume, I have an enum, so you do set collision volume, AABB volume. As for the project, I'm looking at terrain and splat mapping. So that's going to require a custom shader. So I started looking into that and started looking into how Azul loads those in. And I'm not quite sure how that works, but I'm going to keep looking. I couldn't find any good articles on how to do splat mapping, so I just did. I worked out the basic algorithm and did it by hand in GIMP, and it was actually pretty cool. I started to realize some issues of like what do you do when you have stuff over here where multiple channels are on full, or what do you do when all the channels don't add up? Do you have a background color? Is that transparent? What do you do? So that was actually worthwhile.